Hello and welcome to Module 8 of our core Python programming course by Mission AI. In the previous module, we covered errors and exceptions. In this particular module, we're going to cover object-oriented programming. Okay, now this topic generally strikes fear into the hearts of new and young programmers, but it's nothing to be afraid of, right? Uh, it's just a different programming paradigm. So we've seen general purpose programming and procedural programming all this while, but there's also other things like object oriented programming and functional programming. So we'll be looking at OOP right now, okay? And we'll be covering the basic concepts like classes, objects, inheritance, polymorphism, encapsulation, along with some very detailed examples to show you these nuances. So let's get started, right? Now, the first thing we need to understand is what is object-oriented programming, right? And it's just a programming paradigm, which is nothing but a way of kind of looking at the world and a way of breaking down the world and a way of specifying your program, right? To match what you see in the world. So we kind of think of everything in terms of objects, right? And I told you in Python, everything is an object. And an object is composed of two things. One is some data that is in the form of attributes, and the other thing is functions to process that data in the form of methods, right? So remember, a class has attributes and method. Attributes are like properties or characteristics, so you typically represent them as variables. Methods are more like functions. So you define a function within that class, and then you can access that as a method of the object of that class. So what we're doing is we're kind of binding this data and these methods together to prevent unauthorized access by other parts of the code, right? So everything in a class is accessed through the object of that class and through its methods. Now, the advantage of thinking of a real world problem in terms of objects is we can literally define an object for anything, right? Like there are so many different use cases in the world. For example, in a CRM system, CRM stands for customer relationship management, right? So the core of that is the customer. So you'd have a object called customer, and they would have attributes like name, contact details, organization, and so on. And then you'd have methods to get and set these details of the customer. And these methods are typically called getters and setters, right? So a getter basically gets the value of an attribute, and a setter sets the value of an attribute. And the advantage of using getters and setters is you typically don't want to deal with variables or attributes of the class directly. You want to deal with them through a method, right? So only the method that is exposed to the user will be used to like get or set a variable value. So as I mentioned, OOP is one of the many programming paradigms like functional imperative that Python supports. Okay. So now let's get started with the core part of object-oriented programming, which is the object part, right? And when we talk about objects, we must talk about classes also. So what is a class, right? You think about a class as kind of like a definition or a blueprint, okay? And an object is the real world avatar of that blueprint, right? So in a sense, an object is an instance of a class, right? And this object has an ID and reference. So a class basically specifies the entire plan of the object, right? Like what does the class do? What what are its attributes? What are its methods? What is it capable of doing? How does it behave? And so on, right? All that is defined in the class. And then when you build a real world instance of that class, it's called an object. Okay. So if you think of a class like a blueprint or plan for a building, like you have an architect who'll have a plan, right, for the entire building, like you'd have these 3D mappings and everything. The object is the actual constructed real world building. Okay, so that's the analogy you always use to understand the difference between classes and objects. So the best way to kind of understand this is see how it works in code, right? Now I'll explain what I've done here step by step. First, we have a class called building. Now, just like you use the def keyword to define a function, so you say def function name and then the arguments. Here you say class followed by class name, and you could also specify certain things within the brackets over there. I'll tell you about that later, but for now we'll just say class and class name, and then as usual we have a colon to indicate that the class definition is now beginning, and all of this is the class definition which is indented by one tab, right? Now first we create, let's say we created an industry here called construction, okay, because we want to say that all buildings are in the construction industry. Now this is what you call a class level attribute, okay. It means every single object of that class will have this variable with this value when it's created. Okay, so this is called a class attribute. Now, there are certain other things that are properties of the specific instance of that class. That is the object, right? Like, so I could create, now if I'm creating a class called building, I could have one object of that type called building number one, which has, let's say it's a high rise building with 100 floors and 250 apartments, right? Now, those are attributes that are specific to that instance of the class. Okay, so those are called instance attributes. So I could put the name of the building, I could put the number of floors, I could put whether it's residential or not, and these are all instance attributes. Okay, that is, they are specific to the instance of the object. For example, now I could have a separate instance of this class called building number 2, which is just a 2-floor building with 4 flats, and it is a residential building. And the previous building was 100 floors with 250 offices, and it was not residential. So these are instance level attributes, right? The previous thing was a class attribute. So all this instantiation code. So instantiation is basically the creation of an object of a certain class, right? It's contained in this init function. Okay, now init has as its prefix a double underscore and as its suffix a double underscore. Okay, so this is a special name that tells Python that this is the constructor function. Okay, so the constructor function, just like any other function, takes a bunch of arguments, right? Now remember, in any class definition, right, for any method inside that class, the first attribute, the first argument that is passed is always self. That is, the object itself is passed. Okay, now you have to mention self as the first argument inside every method of this class. Okay, and all the other methods you want to specify can come after self. And here what we do is we say self dot name equal to this input name argument, self dot num floors equal to input num floors argument, and so on. So we're kind of distinguishing between this by saying this variable belongs to this instance of the object, while this variable is something that was passed as an input to the constructor. Okay, so the way you access anything in a class inside the class definition is you say self dot whatever, right? It could be a self dot attribute or even self dot method. So now the second method here is a regular or usual method. It's not the constructor method, right? So now this regular method is, it's called print building info, and it takes only the self argument. Okay, so remember one thing: when we define the class, we have to specify self over here. Okay, but when we actually use this class in our code and we, let's say, create the class, we would not pass self, because then Python automatically figures out which object is getting passed to this class definition. Okay, so Python figures out what self is automatically by itself at runtime. So we don't need to pass it explicitly while using this class in our code. But while defining this class, we have to mention self. So I'll say I create this output message, which is a multi-line F string, right? What an F string does is it lets us embed variables in the string definition. So here we go. and then we print the output message, right? This output message that we just constructed, we print it out. So that's what the print building info method of the building class does. Okay. So I have, let's say, from here to here, right? I have defined the class, right? This is the class definition. I used class followed by class name. Then in this particular case, I used a class attribute. I had the constructor function, which is called init, and it took a whole bunch of arguments, of which the first one was self. And I set all the attributes of self using the inputs to the constructor, right? I then defined a second function, a method called print building info, which when I call it, it will take no inputs, but when I define it, it takes only self as the input, right? The argument. And what this does is it prints a custom output message. And that is the beginning and end of my class definition, right? So remember, this is just the blueprint. Now I have to create a real world object out of it and then use that object. So I'll say B, which is a variable, equals building, right? And building is the class name. It's in the same case as build. So B equal to building. And now I am passing some arguments to the constructor. So when I create a new class, right? When I say B equal to an object of building, I'm passing a bunch of arguments to the constructor function because this init function requires these three arguments, right? These are not optional arguments. They don't have default values. They have to be specified. So you can see that I pass three arguments here, but I do not pass self, right? The self argument, Python figures out automatically by itself, so you don't need to explicitly pass it. So Empire State Building, and in this case, I'm passing them as positional arguments, right? So the position of these arguments matches the position of the arguments in this init function exactly. So input name corresponds to Empire State Building. Input number of floors corresponds to 102, and input residential corresponds to the value false. So what this statement means is I'm creating an instance with the name B of the class building, and this instance has these three attributes, right? The name is Empire State Building, the number of floors is 102, and the residential indicator is false. So if I print the type of B, I should basically get class type is building, right? Like I've shown you how to use this type function before, and the class type is building. Similarly, I can also print b.name, b.number of floors, b.residential. These are the attributes of instance B of class building. So B is basically an object. The class type of that object is building, and these are the attributes of the instance, right? Like the self.name, self.number of flows, self.residential. This is the name of the attribute. So I'm using that exact name over here through the object in this particular case. The object is B, right? Over here, which I just created. So I'm accessing the attributes through that object. So I cannot just say print name num flows residential because Python doesn't know what that means. These are attributes of this object. So I need to access them through the object. Now, I'm just doing this directly here, but in the best case scenario, you would wrap these attributes in getter and setter methods so that you don't have direct access. Like you don't want to give another programmer direct access to this class, right? You would allow them to do the manipulation of variables in a safe way. So you would say print b dot get name, b dot get num floors, b dot get residential, which would be methods to access the values of these objects. So those are called getters. And if we want to set the values of these attributes, we would use setter methods. Now, this is how I accessed instance attributes, right? I can use the exact same nomenclature to access class attributes also. I can just say b dot industry, right, which was here. But another way of accessing class attributes is saying b dot And I've shown you this double underscore nomenclature already. I've used it in the case of init, right? Double underscore before, double underscore after. The same thing I do over here. Double underscore class followed by double underscore, and then I say dot industry, just to indicate that industry is a class attribute. And finally, I can say print b dot print building info, or actually I can just call b dot print building info because it just performs an operation, does not return a value, right? And this is the method. This method is also defined in the class definition, and I need to access this method through this object b, right, which I created over here. So I say b dot print building info. So just some important things to note about this code that we just inspected, right? So this class keyword for classes is equivalent of def for functions, right? It's followed by the class name. Now, class attributes have the same value across all instances of the class. You can see that the value is being set to construction. So irrespective of whether I create B1, B2, B3, or any number of instances of this class, the value of the industry attribute will always be construction. So it's a class attribute. The init method is called the constructor. It's used to construct an instance of the class, right? Init is like the special name. It's recognized by Python to contain all the initialization code. Instance attributes typically assign their values inside the constructor, right? So these are the instance attributes. I'm accessing them inside the class definition through the self dot. The object I'm referring to as self and saying self dot name equal to whatever this argument name is, right? So whatever class attributes are there, I'm setting them inside the constructor, which is typically what happens. And instance attributes are specific to a particular instance of the class. So I could create a building called B1, which will have one set of attributes, B2, which will have another set of attributes, and these could be different. Okay. Unlike class attributes, which are the same across all instances. Now, all methods within the class take self as the first argument. You can see that in the constructor function, as well as in this print building info, self is the first argument, right? So any argument that you provide proactively by yourself has to follow the self argument. And I told you this is used only during class definition. When we create an instance of the class, or we call class.attribute or class.method, we do not pass self. Like for example, here we're not passing self. Here we're not passing self. When we create this instance of the class, we're not passing self, right? So self is only used in the class definition. To create an instance of the class, use the class name followed by the constructor inputs in parentheses, which is brackets, right? This is what we're doing. We're assigning it to the variable b, is the class name followed by the inputs in brackets. And to access attributes or methods of the instance, use instance name dot attribute or method name, which is what we've done over here, right? Instance name b dot class attribute industry or dot instance attribute name dot numfloors dot residential and dot print building info. So I hope that gives you an idea of what is a class, what is an object, right? The class is the definition, the object is the instantiated version of that class. That is, it is an instance of this class. And the class has attributes and methods. And once it's instantiated, this instance is created, right? This object, new object is created. And the object's attributes and methods can be accessed only through the object. So you say object name, or rather instance name dot attribute name or method name. So let me run this code above and show you what happens, right? So let's copy the whole thing. Copying it here, pasting it here. So it's the exact same code. I've explained what this code does. So let's try to imagine what the output should be, right? When I say type of B, it should be class type building. When I print b.name, b.numflows, b.residential, I'm printing the attributes of instance b, right? And in the constructor, I had set the value of these attributes as Empire State Building, 102, and false. So in this case, I'm printing the class attribute twice in two different ways. One is using b dot class with a double underscore prefix and suffix, and the other one is just directly b dot industry, right? And I'm finally calling the b dot print building info method, which prints out this custom message containing the instance attributes. So if I run it now, you can see that the first line output is class building, right? And it says main dot building because building is defined within the main program. So this is so what it says is it gives the module name followed by the class name. And the module in this case is main because this is the main program. Now if I defined it in another module, it would give me that module name dot class name. In the second line, it's giving me these instance attributes, which are Empire State Building, 102 and false. And I've printed this class attribute in two different ways, which is the values construction. And then I'm saying b.print building info. I'm executing this method. And what the method does is it prints out this custom message with values, the instance attributes embedded within this message. It's called Empire State Building. It has 102 floors and the residential indicator is false. So that's how we define a class. That's how we define the init function, which is a constructor, and the other methods and the attributes. In the init function, we set the values of the instance attributes. And finally, we know how to create an instance of this class. If you print type, you get the type of the class, and you can print the attributes directly and call the methods directly. Or you could have also used getters and setters to access the attributes. Cool. So let's do our first exercise now. Define a class called vehicle, right? It has one class attribute called domain with a value of transportation. It has 5 instance attributes, right? Engine capacity, fuel tank capacity, mileage, number of wheels, and number of gears. Set these 5 attributes in the constructor, giving default values of 4 to number of wheels and number of gears, and 5 to number of gears. We will have one method called vehicle range that does some calculation and returns the range of the vehicle. We have a method called createDict that returns all the vehicle attributes in dictionary format. So this is the class definition part, right? And then I'm going to say this is the instantiation part, right? Where I create an object of the class and then I do some stuff with it. So let's kind of separate these two. Now the first thing is one class attribute. First define a class called vehicle. So I'm going to say class vehicle, right? And I'm going to say open and close brackets with nothing in between. Basically saying that this is a standalone class. It does not inherit from any other class that I have defined, right? So it's a standalone class. So class vehicle, if I did mention something here, then that would be basically called the parent class. And this is something that we use in inheritance, which we'll look at in the next section. As of now, there's nothing in these brackets, which means this class is a standalone class, right? So what are the things that we have? We have one class attribute called domain with a value of transportation. So I'll say domain equal to transportation, and I'll say this is class attribute, right? Now it has 5 instance attributes whose values I'm setting in the uh, constructor. So I'll say define. Now what is the name of my constructor? It's the init method with double underscore prefix, double underscore suffix, right? And what is the first argument to any method inside the class? It is self. Then we have 5 instance attributes. So when I call the constructor, I'm going to be passing 5 arguments to it potentially. I could also pass 3 arguments because 2 of these have default values, right? So let me just put the arguments as engine capacity, fuel tank capacity, mileage, number of wheels and number of gears. Num wheels, num gears, right? Now num wheels has a default value of 4 and num gears has a default value of 5. So I'll say num wheels equal to 4, num gears equal to 5, and I've shown you how to, like I've spoken more about default values in our module on functions, right? So you can take a look at that just to kind of jog your memory. I think that was module 5. So I'm going to put the colon here to say that I'm now beginning the code block for the constructor function. I'm setting these 5 attributes in the constructor, right? So I'm saying self dot, so basically saying instance attribute, self dot engine equal to this argument that I've passed to the constructor, self dot fuel tank equal to this fuel tank argument that I've passed to the constructor, self dot mileage equal to the mileage argument that I've passed, self dot num wheels equal to the num wheels argument that I might or might not have passed, but if I have not passed it, then it has a value of 4, right? And self dot num gears equal to the num gears argument that I've passed to the constructor, which if I have not passed, it takes the default value of 5, right? So I have created this constructor where all the 5 instance attributes are being set. Cool. So that's the first part of this class definition, right? Now there are 2 additional things I have to do. Create a method called vehicle range, create a method called createDict. So first I'll define vehicle range, right? It returns the product of fuel tank capacity and mileage. So I'll say def vehicle range, right? And again, what is the first argument here? Self, right? Are there any other arguments? No. So I'm just going to say colon. Now define this function, right? So I'll say uh, range. Range is a keyword. So I'll say RNG equal to product of fuel tank capacity and mileage. FUEL tank into mileage, right? And I'll say return range. So that's the first method defined. Now we have a second method called create dictionary that returns all the vehicle attributes in dictionary format. So if I had to say define create underscore dict, and again the first argument and only argument in this case is self, right? So I'm just directly going to return a dictionary where I manually create these attributes. So self.engine is the value that I'm passing, and the key value for that is engine capacity, right? That's the first key in the dictionary. The next key is fuel tank capacity, and the value of that is self dot fuel tank, right? Then the third key of the dictionary is mileage, and the value for that is self dot mileage. The fourth key is num wheels, and the value for that is self dot num wheels. And finally we have the key num underscore gears, which has the value self dot num underscore gears, right? And then I'm closing this dictionary, and that's it. So if I call this create dict method on the object of type vehicle, it'll return a dictionary with all the attribute names and their values, right? And if I call vehicle range, It'll return the product of fuel tank and mileage of this particular instance. Okay, so let's move on to the next part, right? Create an instance of the vehicle class with mileage 22, fuel tank capacity 40, engine capacity 1800, and 6 gears, right? So I'm going to say create instance 1, right? And the second one is create instance 2. Now, if you think about it, like I spoke to you about in functions, right? There are named arguments and there are positional arguments. Now, if I'm finding out the sum of two numbers, right, it doesn't matter which order I provide those two numbers to into the function. They're kind of interchangeable. But if I have five attributes here, right, and defined in a particular order, then there is no way I'm going to remember like which attribute comes at which position. So I will, in this case, specify the the object with named arguments to the constructor. So I'll say v1 equal to vehicle, and I'm going to pass the inputs to the init function, which is the constructor here. And I could have either passed them as positional arguments or named arguments, but I'm going to use them as named arguments or keyword arguments because it's easier to, so that I don't have to remember the positions. So mileage equals 22, fuel tank equals 40, 40, then engine equals 1800, num gears equal to 6, right? And I don't specify num wheels because that has a default value of 4. So at the end of this statement, I would have created instance 1 of class vehicle, right? V1 with all these specific instance attributes and with a class attribute called domain with the name transportation. So now let me create another instance of the vehicle class, say V2 equal to vehicle, which is the class name, open and close brackets. Now I'm passing values to the constructor. Mileage equals 44. Engine equals 200. Fuel tank equal to 20. Num wheels equal to 2. And I'm not specifying number of gears, which means it takes the default value of 5, right? So I've created these two instances of the class. Now I'm going to print out their individual vehicle ranges, right? So how do I access uh, a, an object's methods? So I say object name dot method name, right? And in this case, the method name is vehicle range. So I'll say print v1 dot vehicle range and call the function. So I don't need to pass any arguments here because there's only one argument called self, which Python passes automatically to it, right? Similarly, I can also print v2 dot vehicle range. And finally, how many matching values do their respective dictionaries have? So first, let me run this much code. It says name error, range equals, oh, sorry. So I had just said fuel tank into mileage, right? And this is a problem because what is fuel tank? It's not some attribute that is available all over the place. I have to access the attribute of the object through the object, right? So self dot fuel tank into self dot mileage. So if I run it now, I have the values 880 and 880. So both have the same vehicle range, right? In the first case, it's 22 into 40. In the second case, it's 44 into 20. And you can see that in both these different objects, I've specified the arguments to the constructor function in different order. It does not matter because I've also specified the name of the argument here. So how do I get their respective dictionaries? I use object.createDict, right? So I'll say d1 equal to v1 dot create underscore dictionary. Similarly, d2 equals v2 dot create underscore dictionary, right? So I now have these dictionaries with their respective values, and the dictionaries have the same keys because the same 5 instance attributes are there for all these objects, right? And you remember here, I have not included domain, the class attribute in this dictionary. So I can also include the class attribute here. Let me say domain value is self dot domain, right? So let's say I'm returning 6 values, out of which one is the class attribute and 5 are instance attributes. So at the bare minimum, there should be one attribute matching because this class attribute has the same value across instances, right? So what I'll do is I'll do a simple for loop, right? I'll iterate through the keys of the dictionary. And in this case, both dictionaries have the same structure. So I can just iterate through either of those dictionaries keys. So for k in d1 dot keys, right? It's an iterator of the dictionary keys. If d1 of k equals d2 of k, that now d1 of k gives the value corresponding to key k in dictionary d1. d2 of k gives the value corresponding to key k in dictionary 2. What do I do? So I'm actually also creating a count variable, right? Count equal to 0, right? Count plus equal to 1. So I'm incrementing count by 1 if I find a matching value here. So now let me print count at the end, right? So as of now, it has only one matching attribute, right? Which is the class attribute. Now what happens if I change these values a little bit? So I'll say in this case, num gears equal to 6. Initially, it had taken the default value of 5. So now they have one matching instance attribute and one matching class attribute. So if I run it, I get this count as 2, right? So you can see how I've created this dictionary from the attributes of this object. And it's a combination of class and instance attributes. I calculated the vehicle range of each of these objects using the vehicle range method, and I accessed that method from the object. Okay. And that object I created over here using the constructor and mentioning the class name. So class name in brackets inputs to the constructor function. Cool. So let's move on to the next part now. This is the part where we cover the first the heavy duty concepts uh, after class and objects, right? So we've seen what is a class, we've seen what is an object, we've seen what are methods, attributes, instance attributes, class attributes. We've seen that self is the first argument inside any method in the class, and we've seen like how to create multiple instances of each class, right? And then we've seen how to create a dictionary of all their attributes and then match those dictionaries. So now let's go on to inheritance and polymorphism. Okay. So I'm going to spend a couple of minutes here like explaining these concepts because that's the most important part. Like it'll be very easy for you to understand the code once we go through this part, right? So inheritance. Inheritance in movies and serials is typically what gets passed down, wealth that gets passed down from one generation to another, right? So the concept is very similar here. The basic statement is the child inherits the attributes of the parent, right? And that's what inheritance is. So basically, it's a mechanism in Python where one class acquires the properties of another class, just like the child inherits the attributes of the parents. Okay, so how that practically plays out, I'll let you know. But in terms of real world structures, right? So you have multiple shapes that are possible, right? So if I had a base class, that is a parent class called shape, then that parent class could have multiple children, right? Like one of the shapes could be triangle, one could be rectangle, one could be a pentagon, and so on, right? So each of these children are still shapes, but they all have their own uh, unique qualities, right? Like for example, a triangle has number of sides as 3. The square has number of sides as 4, right? A pentagon has number of sides as 5. Now, they all have an attribute called area, right? But the way you calculate area is different for a triangle, it's different for a square, it's different for a pentagon, right? Similarly, they all also have a perimeter, right? In a triangle, it's the sum of the lengths of the 3 sides. In a square, it's 4 times the length of one side. So all of these have kind of similar attributes, uh, and they all derive from the same parent, which is shape. But the way you would calculate these values for each of them is different. Okay, so some things are common in the fact that they do have a get area and a get perimeter method, but the way you would calculate is different for each of those children, right? So that's what inheritance means. So rather than create a separate class called triangle and a separate class called square and a separate class called pentagon, all of which have lots of code in common, right? I would create an initial base class or a super class called shape, right? Where I define some common properties of all shapes. Like all shapes have an area, all shapes have a perimeter. Uh, the shape might have a fill color, it might have a border color, and so on, right? So that saves me the trouble of having to define each of these attributes multiple times in triangle, square, and pentagon, and so on. Now, I would create triangle, square, and pentagon, and I would say that their parent is shape, the shape class, right? So when I say it's the parent, I said inheritance means the child inherits the attributes of the parent. So all those attributes and methods flow down to the child, which in this case is triangle or square. And I just need to now define the new properties that are unique to triangles and unique to squares. All the common properties are already defined in shape, right? So in a sense, I'm kind of just defining shape once with all these common attributes, and all the children of shape have unique attributes only, and the common attributes can be accessed because they all extend from shape. They are all children of the shape class. So that's what inheritance is. Now, polymorphism means that you can have multiple forms of the same function, right? Now, I just told you that all shapes have a get area and get perimeter method, right? Let's just say. But the way you would run the calculation, like for example, in a triangle, it's half into base into height, right? In a square, it's 4 times, sorry, it's a square, which a is the length of one side. So the I'm calling the same get area function, right? But the the method itself is different between triangles and squares. So that's what polymorphism is, right? I have the same function name, but different implementations of it. So the way a square and circle calculate their get area method is different, and the outputs that they send you will also be different, and they'll return different results, right? So let's look at it with a practical example. I'm going to implement the exact same thing we just spoke about, right? So we want to create a separate class for two shapes, square and circle, right? The attributes of our square are the square has a fill color, which is the color that you paint inside the square. It has a border color, which is the color of the line around, and it has the length of side, right? Which we know that a square is composed of 4 sides of equal length. So I just need to specify the length of one side. Now the methods that a square object might offer are, you can say get appearance, which is like telling us about the fill color and border color. You could say get area, which is length of the side square, and you can say get perimeter, which is 4 times the length of a side, right? Now let's talk about attributes for the circle, right? Now circle also has fill color, circle also has border color, and circle has radius. Where square has length of side, circle has radius. So the methods that the circle object might offer are, you can say get appearance, which is the exact same thing here, where you specify the fill color and the border color. We can have the same method get area, where the calculation is different. It's pi r square, right? And we have a get circumference method, which is similar to the get perimeter method. And here it's 2 pi r, right? So let's say we define square. We have its constructor with three values, right? Fill color, border color, length of side. And the first argument is obviously self. The constructor function is called init with the double underscore before and after. So in this constructor function, we set the values of the instance attributes. There are no class attributes here and only three instance attributes. So we say self dot attribute name equal to input argument name. So now we have three methods here, right? Get appearance, where we return this particular string that contains values from the fill color attribute and the border color attribute. We have another function called a method called get area that returns length of side square, right? This is the square operator to the power of 2, right? Then we have a get perimeter method that returns 4 times the length of a side. And this length of a side is accessed using self.length of side because it's an instance attribute. Now, similarly for circle, you could say we have a class circle, right? And this inside the brackets, it's empty, which basically means it's not inheriting from anything. It's just a standalone class. We have its init method, which is the constructor. This also takes 3 arguments. 2 of these arguments are in common with the square class, right? Fill color and border color. Now the third argument is different. It's the radius, and we're setting these instance attributes in the constructor. Now we have a get appearance method, which is the exact same as the get appearance in square, right? Now we have a get area method, which this also has, but the calculation inside is different. We have a get circumference method, which is analogous to the get perimeter method, but the value is different. The way of calculation is different. So what I'll do is I'll instantiate a square object, right? Using the square class name followed by the inputs to the constructor. So I'll say the fill color is green, the border color is purple, and the side of the square is 15, right? Now C is a circle object, right? So circle is the class name. In brackets, I'm specifying the constructor inputs. Red is the fill color, black is the border color, and 10 is the radius. So now how do I access the attributes and methods of these objects? It's using the object, right? So s.getAppearance, s.getArea, s.getPerimeter, which is for the square, and c.getAppearance, c.getArea, and c.getCircumference for the circle, right? Now, let me run it once and show you how it behaves, okay? Let's copy this code, paste it here, and just run it. So I should have 6 print statements printed out. So first is for the square, fill color green, border color purple, which is exactly what I have here, right? Fill color green, border color purple. And I'm saying s.getPerimeter. Sorry, s.getArea, which is 225, right? So that's 15 into 15, 15 square. And 15 into 4 is 60, which is the get perimeter, right? 4 times the length of a side. Similarly, for C, I also say get appearance, which gives me these things. I say get area, which is pi r square. And I say 2 pi r is the perimeter, right? Now, there is a problem here, and the problem is that there is too much repetition, right? So in this case, I had only 2 classes that I was looking at, square and circle, right? But what if I had 10 such classes, right? For each of those classes, I have to take the same inputs into the constructor. I have to set those instance attributes. I have to define the same get appearance function. I have to define that there is a get area function and a get perimeter function, which have different calculations. There's too much repetition. So what I can do instead is I can abstract away, go one level above, see what these classes have in common, right? Now I know that square and circle are both shapes. I know that a shape has some common attributes, right? In this case, fill color and border color are common attributes. Get appearance is a common method, right, for all shapes. Now, all shapes have a get area method, right? So I can just define a placeholder in the shape thing, saying in the shape object, saying this is a generic placeholder method. And then in each of the children classes, I can define exactly what this value to be returned is. I can also have a say hello function that just returns a string, right? Now the say hello, let's say only belongs to the shape class and not to its children. So in this case, shape is called the base class, right? So it is the base from which other things are derived. Or it's also called a superclass, and its children are called subclasses. So now we have the first subclass. So you remember when we define shape, we have empty brackets here saying that it does not derive from anything, right? But when you define class square, right? In brackets you mention shape, which basically says that I'm defining a new class called square, which inherits from the base class shape. Okay, so in this, I have a constructor, right? The constructor takes all these different arguments, but two of these arguments can be directly set in the base class, that is the parent object, right? So how do I access that parent object from the subclass? I call the super function, right? So super basically returns uh, the instance of the parent class. And then I say that instance dot init, right? So that is the parent's constructor function, that is the init function. I call that function with only two attributes, right? That's what it takes. It takes two attributes here, or rather two arguments. So I'll say super.init with fill color and border color as the input arguments. So what I'm doing is I'm calling the constructor of the superclass. So in the superclass, this self.fill color and self.border color are being set, right? So now the only thing remaining is length of side. So I will set the length of side attribute here because it is unique to the square shape, right? It is not there in all shapes. It is unique to square. So whatever is unique to square, I'll set in the constructor of square directly. Whatever is common to all other shapes, I will set in the constructor of the parent class. Then I have a get area method. You can see that in the superclass there's a get area method, but it returned a generic value. In this case, I'm returning a specific value. Similarly, I also have a get perimeter function, right, which returns the length of the side into 4. Now I'm defining a second subclass called circle. So I'm saying define a new class called circle, which also derives from the shape class, which we defined up here. So this is the second subclass of shape that we're creating, with shape being the superclass. Here also I have a constructor function where the common attributes are being set in the base class's constructor function. So fill color and border color are arguments to shape's init function, right? And the attributes that are unique to circle, which is radius, that we're setting in the circle constructor directly. Now we have a get area method here also, which has the same signature as get area over here, which has the same signature as get area over here, but the way of calculating it is different. Okay, so basically saying that if I create an object of type circle, right, and I say that object name dot get area, it knows, Python is smart enough to figure that I mean return this particular get area corresponding to circle. Okay. Now, if get area was not present in here, then it would look for this method in the superclass of circle, which is shape, and it would return this. So if, for example, I commented out this particular method, and then I said circle object name dot get area, it would return this particular output. So if it cannot find the method in that exact subclass object, it will look in the superclass and return that particular value. So if I say sh equals an object of type shape, right? And it has two attributes that I'm uh, passing, or rather two arguments that I'm passing to the constructor. That is fill color, which is light blue, and border color, which is dark blue. Okay. I'm creating a square. SQ is the name of the object, right? It's the variable pointing to the object of type square. It has three arguments to the constructor function. Two of these arguments get passed to its parent shape, uh, and one of them is instantiated within the class constructor of square. Similarly, I'm also creating the circle object with three arguments. So now if I say print shape, get appearance, get area, and interestingly, I can also call say hello, right? Because say hello is directly there in the, it's a method of the shape object. But if I start printing out stuff from square, what happens is I get the specific method in the square subclass, right? But if that method is not present, then it looks in the parent class and returns that method's output. Like say hello, I did not define it in the square class, right? But square inherits from shape, and the say hello method is defined in the shape class. So it automatically pulls the super classes say hello method. And when I call get area on square, there is a conflict, right? There is a get area in its superclass, and there is a get area method in the square itself. It'll always take the subclasses method as priority. If that method is not present, then it'll take the superclasses method. And then I also print out these bunch of things for the circle function. So let me just paste this. I know it's a very big chunk of code, but don't worry. Let's go through it step by step. And I'll paste it here, right? And before running it, I just want to like take you through these points to be noted. So when we define the superclass, the after the class name, the brackets stay empty, right? Because it's a superclass, it's not inheriting from anything. But when we define the subclass, it is inheriting from the superclass. So we mention the superclass's name in brackets next to the subclass name. Now, in the subclass, we refer to the superclass using the syntax super, right? So super gives us the superclass object, and we say that object name dot init to call the superclass's constructor. Now, we had defined a generic get area method in the superclass. Specific versions of that method are defined in the subclass. So this is called overriding. So as I mentioned, there's a generic get area method, right, in the superclass, and specific versions of that method defined in the subclass. So in this particular case, if I call subclass dot get area, it'll pick up the subclass's specific version of that method. And if it weren't defined in the subclass, then it would get it from the superclass. So overriding basically means I'm defining functions with the exact same name and signature, and at runtime, Python decides which one is going to get picked. So this is called polymorphism, right? Where you have the same name but different functionality. So basically, if there is a method definition in the subclass that overrides the superclass method, then the subclass version of the function is executed. Now the say hello method that we saw is defined only in the superclass and not in the subclasses, but it can still be accessed from the subclass. Remember that the child inherits from the parents, so all of the things that the parents has are accessible to the child object. And for multiple inheritance, like I had specified over here that circle inherits from square, right? Oh, sorry, circle inherits from shape. So there's one single parent class, but I could have had multiple parent classes and I would have had them comma separated inside these brackets. For example, if I were to look at like creating an output template, right? And there were multiple things that it inherited from, like, let's say, font, style, fill, and each of these things contributing certain parts to the overall template. So that's how I would use multiple inheritance, right? And if I wanted to see like which particular method gets called in which particular case, I would use something called the method resolution order, MRO. Okay. And if I say class name dot MRO, for example, circle dot MRO with double underscore before and after, then it would give me the order in which Python goes looking for things. Like first would be circle, then would be shape, then would be object, and so on. So there could be another class that extends the square or circle classes, right? So then we would have shape at the top level, then we'd have square and circle at the second level, and then we'd have the new subclass below either square or circle. And that's what you call multi-level inheritance. Okay. So now running this code above, I'm just going to run it. So this part of the output represents what happened from the shape object that's here. This part of it was the square object, and this part of it is the circle object, right? So let's just deconstruct that output bit by bit. Now, in shape, it is fairly straightforward, right? Like I instantiated the shape object with two attributes, and get appearance touches up on those attributes. Get area is a generic method, and say hello is a method that's unique to the shape class. So this is the output of get appearance. This is the generic get area method, and this is the method that's only in the superclass. Now let's go to the first subclass, which was square, right? So appearance, area, perimeter, and say hello. So first thing is appearance, right? Which is the exact same thing as what's in the superclass. So if you think about it, in square, I had not even defined get appearance, right? Get appearance is defined in the superclass because those two attributes are specific to shape. So in the method resolution order, I would have had circle first and then shape and then object, right? Object is this generic Python object. So over here, if I say print circle, which is the class name, dot double underscore MRO double underscore, that's the method resolution order, and I print it, then this is what I get over here, right? So the first thing is the circle class, the next thing is the shape class, and then finally is the generic Python object class, right? So it looked for get appearance in this particular class, right? It did not find it. So it looked for the next thing in the method resolution order, which is in the shape class, right? Which is right on top over here. Now it found that get appearance in the shape class, so it executed that method. Now get area again follows the same MRO, right? It looks first in circle, then in shape. So now that get area is present in square, it takes the get area method defined in square. It does not take the one defined in shape. Now get perimeter is defined in square, right? So it takes both these from this subclass itself. Now say hello again is not present in the square class, right? Say hello is a method that's unique to the superclass, but those attributes get passed down to the child. So that's how I access it using the same subclass. Exact same case in the case of circle, right? Get area, There is a specific method and the generic method, but because of overriding, which is polymorphism, it picks the one in getArea defined in the circle. GetCircumference is unique to the circle class. SayHello is only present in the shape superclass, so it picks it up from there. So I hope this kind of cements your understanding of base class with nothing passed in the arguments to indicate it doesn't inherit from anything. Then you have the subclass, which inherits from the superclass, in this case, which is shape. We have method resolution order that kind of determines where does Python look to execute a particular method. Like if I say this object dot get area, then where does Python start looking? So first it looks inside circle, and then it looks in the class that circle inherits from, right? And then it looks in the object class that's part of Python standard library. So let's do an exercise now. And this is a humongous exercise, it looks like, but I mean, I don't think it's going to take us too long, right? It's more details, but the concept is very simple. So we want to define two different classes, right? Car and aeroplane, which are both modes of transport. They have some common attributes, right? So let's just say two classes, car and plane, right? Uh, Common class, you can say, is transport. Now, I'm just writing a bunch of details here, right? It makes it easier to summarize. They have common attributes, right? Manufacturer, model, fuel tank, capacity, mileage, whatever. So let's say common attributes, right? And they also have a common method called getRange. It returns fuel tank capacity into mileage. Now, both these cars as well as planes have a fuel tank, so they have fuel tank capacity. They both have mileage, and the product of those two things is the getRange method, right? So I'll say common method equal to fuel tank capacity into mileage. So I have the common attributes and methods, and there's this common class which is transport, right? So I'll just move it down here. And two classes derive from transport, so I'll call them two subclasses, right? Car and plane. Now, cars also have some unique attributes and methods. Planes also have some unique attributes and methods, right? So cars have unique attributes like number of gears and left-hand drive indicator. Right? And car also has some methods which are unique to it, right? The get price, I can say it's a common method in the sense that the name is the same for aeroplane and car, but the way you calculate it is totally different. So I'll say in this case equal to engine capacity into 1000, right? So I have my, I'll call it first subclass car, and then I'll say second subclass plane, right? Now, what are the plane attributes? Jet engine indicator and body type, right? So let's say jet indicator, body type. And what are the methods that are unique to planes? Get price, which is calculated as its range multiplied by 10,000, right? So the name of the method is the same as that of cars, right? But the way of calculating it is different. Now, what else do they have in common? They have a get dictionary method, right? That returns all their attributes and values in dictionary format. So we could add it over here, right? So get range is one thing, get dict is another method. And we can say that that method exists here also because car has some attributes that are not in plane and plane has some attributes that are not in car, right? So let the superclass also have a generic get price method that doesn't do any calculations, right? So let's say it has get price and I'll say here is generic. Okay, cool. So let's start defining this. Let's start writing code for this entire thing now. So I'm going to comment out this. So I'll call this the summary slash problem understanding, right? So there's a common class called transport, which has some common attributes which are the same to cars as well as planes. It has some common methods. And then there's the first subclass, which has some unique attributes that are different from planes as well as methods. And the plane has unique attributes and methods that are different from cars. So first I'll define the parent class, right? So I'll say class transport, and it does not inherit from anything, so empty brackets. Now this starts the class definition, right? And there are no class attributes, there are only instance attributes. Now manufacturer, model, engine capacity, fuel tank capacity, mileage, these are attributes that are common to all modes of transport. Let's just say, right now, bicycle obviously wouldn't have it, but let's say if I were to say motor transport, right? Then all modes of transport have these attributes. So I can include those attributes in the superclass, right? So I'll define the init method first, which is the constructor with double underscores. And the first argument is self. And the next five attributes are all these things here, right? So I'm going to say manufacturer, model, engine, fuel tank, and mileage, right? So these are the five attributes common to all forms of motor transport. So what do I do inside the constructor? I'll assign values to the instance attributes. So I'll say self dot manufacturer equal to the value that I passed in the as an input argument, which is this, right? Similarly, self dot model equal to model. Self dot engine equal to engine. Now I could have also done things like, just to make it less confusing, if you are confused by this, I could have said f comma m, right? So as the input arguments, like my class would still have the same attribute names, but the input arguments names would be different. So I say self dot fuel tank equal to f, self dot mileage equal to m, right? So what's on the right side of this is the input arguments that we pass, and what's on the left side is the instance attribute. Okay, so I've defined the constructor function that initializes these common attributes. Now I'm going to use the get range method. So all motor transport has a fuel tank capacity, which is here, right? All motor transport has mileage, which is passed in this attribute, which is initialized here. So just the product of those two things is going to be the get range. So I'll say define get range, taking self as the argument, the only argument here. And I'll say return self dot fuel tank into self dot mileage, right? So if I say I have a fuel tank of 40 liters and my mileage is 22 kilometers per liter, then 40 into 22 is my vehicle range. And let's say there's a generic get price method, right? So define get underscore price, which takes self, and it returns this generic string output. Okay, so this is the superclass, which is motor transport, right? Now, car and plane are both types of motor transport. They have different kinds of motors and they have different kinds of attributes and methods, but they also have a whole bunch of stuff in common, which is captured here. So let me define the car class now. I'll define it here. So class, which is the keyword, car, right? Now, does car inherit from something? Yes, it does. It inherits from this class, motor transport, right? Now, does it have any class attributes? No, it doesn't. It has only instance attributes. So define init, which takes all these attributes plus two unique attributes, right? Which are these two things. So remember, like if I have a subclass, right, which is a specific or extended version of the superclass, and the superclass has 5 attributes, then the subclass has 5 plus n attributes, where n is the number of unique attributes. Okay, so all the common ones have to be passed to the constructor as well as the unique ones. So I'll just copy this over here, right? And let's say there are two new unique attributes here called num gears and left hand drive indicator. Now instead of writing left hand drive indicator like that, I can just probably call it LHD indicator. I'll put the colon. So now you can see that this constructor has 7 arguments, right? So what am I going to do with these 7 arguments? I already have a superclass constructor that initializes 5 of those attributes. So what do I need to do in this case? Let me call the superclass constructor using super dot init, right? And to this init method, I pass the first 5 attributes, right? These are what is common across motor transport. So these 5 attributes are initialized here, and these 2 attributes, sorry, I don't need to, that was a mistake. I need to still pass all these 7 to this constructor, and then I need to pass 5 of those to the superclasses constructor, and the 6th and the 7th ones I'll initialize here itself in this instance. So I'll say self dot num gears equal to num underscore gears, self dot left hand drive indicator equal to LHD indicator, which is the input argument to the constructor of the car subclass. Okay, so using this one line of code, I called the superclasses constructor with the arguments that it required, and 5 instance attributes have already been initialized over here. Okay, and the 6th and the 7th ones are explicitly initialized in here. Now, what are the car methods? Get price. So define get underscore price. Doesn't take any arguments other than self. It's basically engine capacity into 1000, right? So return self dot engine into 1000. And then there is also the get dictionary method, which returns all these attributes in a dictionary form, right? Now, 5 of these are in common across car as well as plane. So why don't I just create a method here in the superclass that returns a dictionary containing those 5 elements, right? So define get underscore dictionary. So what am I doing here? I'm taking the object itself and I'm creating a dictionary out of 5 of these attributes, right? In this particular case in motor transport, only the 5 common attributes are present. So I return that to this function, and this function adds the 6th and 7th entries to the dictionary. So I'll say return a dictionary object, and I can just copy this code from above here. I saw it somewhere, right? Let's go further up, and here we go. I'll just copy that code, which we've already written, and I will paste it here, right? So number of gears, number of wheels, mileage, fuel tank, engine. These are the common attributes, right? No, these are not the common attributes. So I'm going to create a dictionary with the values, with the common attributes here, return it here, and then add the 6th and 7th values. So let's just start creating them. So the first one is called manufacturer, and it's self dot it's manufacturer. That's the value, right? The next key is model, and the value is self dot model. Then the next key is engine capacity, and the value is self dot engine, right? Next key is fuel tank capacity, and the value is self dot fuel tank. And the final key is mileage, and the value is self dot mileage, right? And I close the dictionary, and that's it. So this dictionary function in the superclass just returns um, the 5 attributes in a dictionary form, right? So in the subclass, what I'll do is I'll say super dot get dict, right? So now, and I'm going to assign it to the dictionary value D. So it's returning a dictionary. I'm going to catch that dictionary, and I'm now going to say D of, what are the unique attributes here? Number of gears. Num gears equal to self dot num underscore gears, right? And D of left hand drive indicator equal to self dot LHD indicator. So using this get dictionary method calls the superclasses get dictionary method, and it then adds these 2 unique attributes, right? So I have to mention self over here. And I don't need to like pass self here because I'm actually calling this method here. Only where I define it, I have to add self, okay? Cool. So that brings us to the end. Are these the only things? We have get price and get dictionary. Yes. So the definition of the car class is over. Now let's define the plane class, right? So class plane, right? This also derives from the motor transport superclass. So let's add that in the brackets. Now the plane has a whole bunch of unique attributes, or rather 2 unique attributes, and most of the attributes, the 5 others, are in common with car, right? So I'll just copy this here and paste it here. So in the constructor of the planes subclass, I'm passing this same first 5 arguments. The sixth argument is jet engine indicator, and the seventh argument is body type. Okay. So now using the first five common attributes, I pass that to the superclasses constructor, right? Which is the motor transport superclass. We've already seen how to do that with the car subclass. Now the sixth and seventh attributes I'll initialize here itself. So self.jet engine indicator equal to this, and self.body type equal to this value, which is the input argument, right? So that's the constructor. Now it also has a get price and a get dict method. So I'll just copy both these things from car. You can see that although the function signature is the same, the calculation itself is different. Okay. So in the case of the plane, range is the get price is range into 10,000. Now range is again something that has to be calculated, right? How do I get range? Range is there from the superclass, which is the motor transport class, right? So I'll say super.getRange. Super.get_range into 1000, or rather into 10,000. That's the value. So that's the price of the plane, right? And to get the dictionary, I call the same superclass, and that creates the first five values, and the sixth and seventh are unique. So I'll just change that here. So I have the get dict method also defined. So get price has the same signature in car and plane, but the implementation is different. And get price is there even in the superclass, but it has a generic output. So if I call this subclass and I call get price on it, it'll override the superclasses method and it'll give me the subclasses output. Cool. So now let's move on to we defined our classes, right? So the blueprint is ready. Now we have to actually build the building. So that's here. So now what I'm going to do is create that car below the car class, create the plane below the plane class, and then call all the methods of the newly created objects here, right? So under the car class definition, I'll create an instance of car, C equal to car, and I have to pass the arguments to the constructor. And now car has five common attributes with like motor transport, which is inherited from motor transport. And it has two unique attributes here, right? Num gears and LHD indicator. So let's pass these arguments to the car constructor function. So factor, and I'll pass these as named arguments because there are too many to remember the order. Equal to Ford, model equal to Mustang, engine equal to 300, fuel tank equal to 60, mileage equal to 5, num gears equal to 6, and LHD indicator equal to true, right? So these are the input arguments to the car class, right? Which extends the motor transport class. So I've created this particular instance of that class, right? So now I'll create a similar instance of this plane. I'll say P equal to plane, and the manufacturer is Airbus. Model is A320 Neo. Engine is 21,000, let's say. Fuel tank is 22,000. Mileage is 0.2. There's no variable called number of gears. And jet engine indicator is a variable, which is true. And body type is narrow. Cool. So those are the arguments to the plane constructor. And that in turn passes these first 5 arguments to the motor transport constructor. Okay. So let's just print out all the values from these different objects now. So print, first I'm going to do for car, c dot get price, c dot get dict, right? C dot get underscore dictionary. Then I'm also going to say C dot get range, which is from the inherited from the motor transport superclass dot get underscore range. So those are the methods for C, which is car, right? Now I'm going to do it for plane. P dot get price, P dot get dict, and P dot get range. Cool. So if I run this, I have a type error, got an unexpected argument on line 59, which is here. Oh, so I had to put them as F and M, right? So I'm just going to say F equal to 60 and M equal to mileage. I just want to, I mean, I changed these names to show you uh, like how it could accept the input argument could have a different name from the instance attribute, right? And I'll do the same thing here also. F equal to 22,000, M equal to mileage. So if I run it now, I get one set of print statements with the car values and one set of print statements with the uh, plane values. But the crazy part is they're not returning any. Oh, sorry, I did not return this value that was there in the dictionary. So in this case, I returned it back to the subclasses, but from here I didn't return it back to the calling location. So I'll say return D. If I run it now, you can see that this dictionary also gets printed, right? With all these attributes from the instance. The above one is for car, the below one is for plane. So that brings us to the end of this talk on inheritance and polymorphism, right? So I've shown you a case where we have this motor transport class, which is the superclass, that there could be many types of motor transport. And this class contains all the common attributes between the forms of motor transport, right? And it accepts these arguments to its constructor function. It has a few generic methods like get price, where it doesn't do any calculations, but it's like a placeholder. It also has get range, which returns the product of the fuel tank and the mileage. And then there is a get dict method that returns a dictionary of these 5 attributes that are in common. Now the car superclass has 2 extra attributes. In its constructor, it calls the superclasses constructor. It also has 2 unique methods called get price, where the calculation is different from this particular calculation. And the get dict method, it calls the superclasses get dictionary method. It adds 2 additional keys which are unique to the car, and it returns this, right? And in the plane, we have a similar kind of structure, right? We have 2 unique attributes to plane which are different from car or any other type of motor transport. So for the 5 common ones, it calls the superclasses constructor, passing on the first 5 arguments that it's received to the superclasses constructor. Here we have a get price that has a unique calculation. It does range into 10,000, and range is accessible through the super function. And we have a get dict method where the first 5 are from the superclass and the next 2 are unique to the subclass, and it returns this dictionary. Then we instantiated both these objects, passing keyword arguments, and then we call these different methods on the car and plane instances. Okay, so we'll continue with our talk on object-oriented programming. We'll cover encapsulation using access modifiers, as well as like using inheritance and polymorphism to extend Python functionality in the next video. See you there.